let's get started. Hello everyone and welcome to yet another recreation programming session with Mr. Zozin. On the previous stream, we developed a multiplayer game prototype in a browser, right? So as you can see, we have a simple game. I know that it doesn't look like a game, right? So, but that's the point of a prototype, just to have something that you can test things on, right? And it is truly multiplayer, right? So essentially, if you open localhost in a second tab, right, so you have now two players, right? So you can move around in one window, right? You switch to another window and you can also move around, right? And how many windows you create, essentially this is how many players you're going to have. So we can open another one and there will be 3 of them, right? So it generated like a similar call. Let's actually refresh a couple of times. Yeah, so now we have a blue one. Right, so this is how it looks like, and all of that is implemented using WebSockets, right? So we have a WebSocket server that listens for input connections, right? So, and when you open the web page in browser, it connects to that WebSocket, and this is like a very simple prototype of the multiplayer game, right? You can find the source code of this entire thing in the description for YouTube people and for people in the chat. I'm gonna put that in the chat in here. So I wonder if I put it in the description. Yeah, I did in fact put that in the description. So the problem with this entire thing is that I have no idea how to make multiplayer online games, right? So this is my first attempt at making them, right? And I don't even know if I did everything correctly, but so far so good. It seems to be working. It seems to be working. So I must be doing something correctly, at least something, not everything, but maybe something I'm doing correctly. Right, so, and from here, I would like to start improving this entire thing. And to improve this entire thing, I probably need to collect some statistics, right? So maybe some profiling and stuff like that. I actually outlined the list of things that I would like to collect statistics about, right? So this is basically the thing I want to know. Like, for example, an average time to process a tick. So on a server, we actually simulate the game, right? You know, when you play like a single player game, you have frames, right? But on a server doesn't really render anything, right? It usually doesn't even have a monitor, right? So what it does, it still simulates the game, but it simulates the frames like ticks, right? So I would like to know like how much time it takes to simulate a single tick on a server, right? I think that's kind of useful. Right, we communicate between client and server by sending single messages over the WebSocket connection. It would be kind of nice to know how many messages the server sent and how many messages it received from the client, so we know the total amount of traffic. Right, and the most interesting part is that how many on average messages we send per tick, and how many messages we receive from the clients per tick. Right, so the hypothesis I have is that if we send or receive too many messages, specifically send, right? So if we send too many messages, it may take like a lot of time doing that, because I presume that the network is a very slow connection, right? So you probably don't really want to send too many messages, right? And maybe one of the optimizations we can do to reduce the amount of messages sent, we can just basically bundle them somehow, right? So we need to implement some sort of bundling, and maybe also switch from JSON. Right now we're packing our messages into the JSON, right? So which is probably wasteful. But again, I'm doing this kind of stuff for the first time, and the way I work is I implement the dumbest solution possible and just see what I can improve. Right, so, and maybe one of the improvement would be to just switch to a binary protocol, right? So people will instantly go, oh, protobufs, but to be fair, I don't really want to use protobufs, right? Because I briefly looked into it and it looks like a huge of a dependency for something that I can literally do myself. It's not like, look, I programmed a lot in low-level languages. I'm not a web developer who's afraid of bytes. I'm not fucking afraid of bytes, right? I can create uint8 array and just, you know, poke into the bytes directly. I'm not some sort of like a soy web devs who's afraid of uint8 array and needs protobuf and stuff like that. I can do that. I programmed in assembly. I fucking wrote a website in assembly. I'm not even joking, by the way. So yeah, I think it's to do awesome. Right, so let me see. Yeah, there we go. I wrote this kind of shit. I'm not afraid of bytes, you know? I'm not afraid of bytes. So I'm going to put that in here. And for people who's watching on YouTube and interested in this kind of shenanigans, I'm going to put that in the description. So yeah, we're probably going to switch to a binary protocol, but I'm going to try to not use protobuf. I'm going to try to just like implement my own thing, and I just don't think it's going to take too much time to implement. It's actually pretty simple. You just like, you know, generate the bytes and send the bytes, right? So what's so special about that? Especially considering that JavaScript on browser and in Node.js provides you such facilities as float 32 array, right? So you literally can take an array of bytes and reinterpret it as array of float 32 numbers. You can literally do that. Like it's super fucking convenient. You don't even have to encode shit yourself. JavaScript already provides you enough facilities to do that. It's super convenient. It's even easier than in C. Well, I mean, you can also do this kind of shit in C, right? But I mean, so yeah, there's no reason to be afraid of bytes in JavaScript, right? There's no reason to be afraid of bytes in JavaScript. So yeah. But so that's a lot of interesting statistics, but to collect all of that, I need to have more players than one or two. I need to like maybe 100 of players, right? I can try to ask the chat to stress test the application, but to be fair, chat is unpredictable, right? And I want to have a control over exactly how we stress test our application. And because of that, I want to build an army of bots. So yeah, I want to build an application that creates several connections to the server, creates a bunch of bots that move around in a certain pattern to create sort of like an artificial traffic. So then I can collect these kind of statistics and see what I can improve, what are shortcomings of the server and stuff like that. Right, and it's going to be like a stress testing tool that I'm going to be using to improve this kind of stuff. So, and that's going to be the topic for today's stream, right? So we're going to implement like the army of bots for stress testing this entire thing, right? So essentially, it's probably going to be like a second client. So the first client is, you know, the browser thing, right? So that runs in a browser, and the second client is going to be a thing that also connects to the same server, but it creates like things that move by themselves, right? Sounds good? Sounds Gucci? Sounds what? Tamaguchi. So let's go as usual. So yeah, let's go ahead and do that. So what we're gonna do, I suppose what I want to do, I want to create bot MTS, right? So I want to create bot MTS, and let's actually do console log, and let's say hello from a bot from bots. Bots. How can I run the bot? So I probably need to create like a separate command. So I know there's this thing npx, and I think I can just run this entire stuff like this. Can I do that? Yeah, almost, right? So I can almost do that. So there is empty. Oh, it's called bot, not really bots, but just bot. There we go. So we have hello bot. So I can actually run things through npx in here. So if I remember correctly, npx just like set up necessary paths and stuff like that. So it's pretty convenient to do it like that. So the reason why we'll need npx in here is because this thing will depend on the Node.js WebSocket implementation, right? So let's actually import this thing as ws from ws, right? So, and if I just try to run it like that, it still kind of worked actually, surprisingly. Like, huh. Is that because, wait a fucking second. If I take a look at the MJS, look at that motherflipper. That motherflipper actually stripped off this import because I never used anything from it. Fuck you, Leatherman. I wonder what's gonna happen if I just say, okay, import WebSocket. Import WebSocket. So, and then I take a look at the MJS. Bot MJS. So what do we have in here? It's still stripped it off. This motherfucker still stripped it off. I wonder if I just like create something like const ws new WebSocket, right? So now I do in fact use this entire thing, and let's go to here and revert this entire stuff. And finally, it didn't strip off this entire thing. Look, TypeScript actually optimizes things. Who would have thought? Who would have actually thought? So, and now if I try to run this entire thing, it will tell me that, yeah, well, I mean, it still managed to do that. Interesting. Like, apparently I don't need npx or anything like that. It automatically just uses ws. I wonder if maybe ws is already part of the install thing. Interesting. Okay, so that's fine. That's totally fine. I guess I learned something. Okay, so what do we have? I probably also need to import the common stuff, right? So, and the common is basically the code that is shared between the client and the server. We have quite a few things in here, 153 lines of code. It's basically the models, some shared constants and stuff like that. Like, for example, a server port. This is one of the things that we probably need to have in the bot. So as common from common MGS, right? So, and in here I probably want to do something like WS. Well, I mean, I have to do that in a string literal. So this is going to be localhost, and this is going to be common server port, right? So server port, and so that should be it actually, right? So that automatically creates a connection. So let me see if I do something like that, right? So if I just start the bot, it created a connection. Look at it. It just created a thing, and now I can kill this entire stuff and run it again. Yeah, so essentially to create a player right now, you just have to connect to the WebSocket server. You don't even have to send anything, right? So maybe this is a shortcoming of our protocol, right? So maybe we should obligate the player to send something. But again, this is just a prototype. So who cares, right? Well, when we start to integrate that into the main game, right? So, and we are making that prototype for the game that looks like this. So let's actually see for the raycasting game. So eventually this thing is going to be multiplayer, right? So this entire thing is going to be multiplayer. I'm going to give the link to this entire thing in the chat, and also I'm going to put that in the description for people who's watching on YouTube, right? So that's basically the long game, right? So this is the long game that I'm playing right now. So this is going to be prototype, but then once I figure out how to do this kind of like multiplayer things, I'm going to integrate that into here, and then at some point it's going to be like a multiplayer game. So I think it's going to be cool. Really looking forward into that. Okay, so we can actually connect to this kind of stuff, and maybe I can steal some I don't know, some code from the client itself, right? So the client using the browser WebSocket implementation, but maybe that's totally fine, right? So here's the handler that handles the messages, right? So, and the thing about this handler, fly check mode, right? So I literally copy-pasted a chunk of code from the browser implementation of the client, right? So I literally copy-pasted that. Because it's rather convenient. So it has a variable called me, which points at the player instance of me, right? So let's actually take a look at it. So where is me? Yeah, there we go. Me is either player or undefined, and player is just a structure that stores the ID of the player, the X and Y, how the player is moving, what kind of style player has, which is the, you know, the core and stuff like that. So we'll probably need to have this kind of variable somewhere in the bots. So it doesn't have a player. So I suppose one of the things we want to do, we want to import the player from the commons, right? So this is going to be from common MGS, right? Right, so, and since it's a TypeScript, I have to do this stupid shit import type. All right, so it doesn't like something about the event. What does it say? Oh yeah, okay. That's annoying. So in a Node.js implementation of TypeScript, the data has the type data, which is either string buffer or array buffer or something like that. But in a client, in a browser specifically, if I take a look at the data, what's data? It's actually any. Right, so it's kind of funny to have a universal code that needs to work between Node.js and browser. Do you guys know the concept of universal code? Right, so universal code is like a piece of code that works both on the server and client. right? So isn't that like the huge big things in Next.js, right? Like a server-side rendering or whatever the fuck it is. So you have a piece of code that is runnable on both the browser and the server. Is that the new thing? Right. So we're doing that, by the way. We're doing that. So, anyways. Right, and in here, so there's a little bit of a discrepancies between the Node.js WebSocket implementations and the browser, but I suppose it's not that big of a deal, isn't it? Right, so we can just do something like toString, and there you go. Everything, as you can see, is Gucci and, in fact, Tamaguchi. So, yeah, this is another thing that we probably want to do. We just want to do toString. And here we have a map of players, right? So this thing is supposed to keep track of all of the players. All right, we can try to do that as well. Do we really even need to keep track of all of the players, right? So since we need the bots to just move around, they probably should not be aware of other players. We probably don't even give a fuck. But I mean, let's just like do that just in case, because who fucking knows? Maybe we'll need this kind of stuff. Maybe we will need this kind of stuff. All right, and it compiles. Okay, so I just, yeah. I just copy pasted some stuff from the client and that seems to be working, right? So it doesn't really do anything particularly useful, so I don't really even fucking know. So yeah, the player joined and we even like, you know, have information about the other players and stuff like that. One of the things we can do, okay, listen. So we just joined, we can right away send some sort of a message, right? So we can do send message and we can say I'm moving. So, and this is a message that tells the server that we're moving in a certain direction. So it usually tells you whether I'm holding the key in a certain direction or I release the key from a certain direction. So in that case, I have to stop. So so this type is I'm moving, right? So this is I'm moving. And what's this type is about? So it has kind, right? Starts indicates whether you start moving or stopped moving, right? If it's true, you started moving. It's if it's false, you stopped moving. And direction indicates the direction in which you're moving, which is like left, right, up, and down, right? So nothing particularly special. So this is basically what we have to put in here. So, but we need to have the WebSocket. So kind I'm moving. So then we say that, okay, so we're starting moving, right? So this is true. And then the direction, in which direction we're going to be moving, chat? In which direction we're going to be moving? We're going to be moving to the right, right? So let's move to the right. So okay, so let's actually try to do that. And so yeah, as you can see, the server received a message from player 10. I'm moving, start true, direction right. So this is the log of the server. This is the log of the bot. Yeah, and it is moving. Look at that. Look at this motherfucker. It's moving to the right. All right, so that's pretty cool. I can now kill the bot and bot disappeared. Bot disappeared. We can now make it move to the left. All right, so, and now if I start the bot, it's moving to the left. I suppose I can actually do something like, I can start another bot. Who said I can't do that, right? So let's actually maybe put it in here. So can I do MGS? And now we have two bots that moving along, right? So you can kill that. You can create another one. Right, so you can already like stress test things, right? So you already have this kind of shit. But that's kind of boring. To be fair, I would like them to maybe wander around. So essentially, maybe they're going to just pick a random point in the world, right? So a random point in the world and just move to that point. And as soon as they reach that point, they're going to pick another random point and go to that point. And then again, another random point and like that indefinitely, right? So I think that sounds good, right? So, and it will basically like simulate just players wandering around, right? So it will simulate the players wandering around. Give us the control. We'll do that at some point. Don't worry about it. So how can we do that? So let's maybe introduce some sort of a variable. So maybe goal x, and maybe it's going to be like a math random. I want it to be predictable, to be fair. For the testing purposes, I want to know where exactly the bot is going to be moving. So let's actually do common world width, right? So it's going to be half of that, and goal y is going to be is going to be the height, right? So, and how are we going to be moving to that thing? Right, this is very interesting. This is a very interesting, my friend. All right. So, imagine we have a world. Imagine we have a world. So this is the goal, and this is our player position. So how can we move that? We can just basically, you know, make it move diagonally. But I mean, we can't move at any angle. We can only move, you know, vertically, horizontally, and diagonally 45 degrees, right? So we can't just right away move to the particular point. So one of the strategies that I'm thinking about is that maybe move like a Manhattan style, right? So basically first move here and then move here, right? You guys know Manhattan distance, right? So it's basically not this kind of distance, but the distance of this plus this. So this is a Manhattan distance, right? I think it is called Manhattan distance, isn't it? So Manhattan distance. Taxi cab geometry. I mean, okay, so but it has many names. Yeah, Manhattan geometry. Yeah. The length of red, blue, green, yellow all equal to 12. Yeah. So something like this, basic. Taxi cab geometry. I'm gonna put that in the chat for anyone who's interested, and for people on YouTube, maybe I'm gonna put it in the description. Yeah, additional information. So maybe we're gonna actually do it like that. So, and so that means we have intermediate points, right? So we have end goal, right? We have some sort of an end goal, and we have intermediate points. So how are we gonna be approaching that? So we probably need to keep track intermediate points, but then we need to wait until we reach those points or something like that. I just realized Wikipedia is not asking for money anymore. That means they got enough. They got enough money. So I suppose maybe okay. What I'm thinking is we can have some sort of a like variable that keeps track of how long we have to wait. How long we have to wait. So first of all, we need to organize the sort of like a tick loop, right? So just like with the client or with the server, we need to have some sort of a loop that also simulates the player on the bot side, right? So they, you know, have a copy of their approximation of the state of the game, right? I think this is one of the things we'll have to do. Since bots also don't have any surface area where they are drawing things, we're going to be using like a set timeout or something like that. We also need to pick the FPS at which the bot is going to be simulating things, right? So let's do 30 FPS, right? So maybe something like bot FPS is going to be 30, right? That doesn't really matter. In any case, the server is going to synchronize things for us anyway, right? So we can just pick whatever. So let's actually do set timeout, right? Set timeout. What do we have in here? So we have to do callback. Let's introduce a function tick, not functions, but function tick. Right. So this is a function tick. So this is tick, and the timeout is in milliseconds. So that means we have to do 1000 divided by bot FPS, and we have to keep repeating this entire thing. But on top of that, we also want to have the delta time, which is in seconds, right? So timeout takes shit in milliseconds, but we need to have this kind of stuff in seconds, because this is what at least common update player expects, right? So it expects delta time to be in milliseconds. So let me now try to do this kind of thing. So this is going to be 1 over bot FPS. So there's a little bit of difference between the measure units and stuff like that. So and then here, what we're going to be doing, so we have the players, right? So we have the players, and the only thing I suppose we're going to be doing is players for each, right, for each player, we take the player and we just, you know, update the player. We just simulate the player. So it's going to be player with the delta time that looks like this. So there we go. So this is what we have in here. Cool. So and essentially, we are going to have some sort of a variable that keeps track of the time for how long we're moving to the intermediate point. Right, essentially, we're going to pick a certain direction and we're going to be just letting the player move in that certain direction for a certain amount of time, right? And when that certain amount of time runs out, we have to assess the situation, right? We need to look around and make another turn, maybe like move a little bit further or maybe turn around or something like that until we reach that specific goal. So that's basically the idea that I have, right? So we need some sort of a variable, which is basically like a time out before turn or something like that. But we also need to have an indication that we reached the goal, right? So essentially, maybe that indication is going to be that this variable is undefined. All right, this variable is undefined. So it can be either undefined or number. Right, and if it contains a number, that means we're waiting, we're moving to intermediate point, right, and it keeps track when we have to stop and consider another turn. And if it's undefined, that means like we're not waiting, we're not moving anywhere, we probably reached that specific point, so there's nothing to worry about. Something like that, something like that. And we can always compute this variable because we know the distance to the intermediate point, right? And we know the speed of the player, right? The speed of the player is literally encoded in here, right? So we literally have a player speed. Who remembers the school physics, right? You take the distance divided by the speed, you get the time. Right? Time is the distance divided by the speed, by the velocity, right? So that should be pretty straightforward. We all learned that in school. At least we did. This is what we were studying in school. So yeah, should be very straightforward. So anyways, and okay, so in here, right, so maybe we're gonna actually assign this kind of thing in a separate function like turn, right? And in here, what we're gonna do, we're gonna take a look at the current player, right? So, and the player obviously has to be, you know, defined, right? So this is not undefined, right? And we need to make, first of all, we need to clean up all of the moving states of the player, right? We need to clean up all of the moving states of the player. So that means we have to iterate through all of the movings of the player. Right, player has this field called moving, which is basically an array of booleans, and there is 4 booleans in here for each of the direction, right? So left, right, up, and down. So true indicates that you are moving in that direction, false means that you're not moving in that direction. Pretty straightforward. So what we want to do, we want to basically direction in moving, right? That's what we want to do. And if me moving is true, we actually want to set this entire thing to false, but that is not enough because this is just a local state. This is just a local state. We'll have to notify the server that we want to stop, right? So how we're going to be doing all that? We're going to be sending a message, right? So send message to the server me ws. No, WS is actually a global thing. Yeah, so it is in fact a global thing. So WS, we're going to be sending a message, I'm moving, right? So I'm moving. So here we're going to have a kind, I'm moving. The start is going to be false, indicating that we want to stop moving in that specific direction. So something doesn't compile. I don't really know why, because it says me. Element implicitly has any type because expression of string cannot be. Oh, this freaking stupid TypeScript. I remember that. I think you have to do some stupid shit like this. Yeah, it's yeah. I think that's what you have to do. Yeah, there we go, because it can't. Freaking TypeScript, like for real. It knows that the key of this thing is a direction, but it's still incapable of deriving that in here, even though I explicitly say direction in here. So I would literally expect this thing to derive that the key is a direction. So you have to explicitly tell it. It's just like TypeScript has the most sophisticated type system I've seen, and yet sometimes it fails to enforce this kind of stuff. Maybe I'm doing something wrong. So it's off. As far as I know, off is going to give you. I'm not even sure if it's going to work for the objects, right? Is it going to work for the object? No, it doesn't even work for the objects. Yeah. Nah, it's not going to work. We have to do something like that. Anyways, so we cleaned up the entire sort of like state, right? And now we kind of need to know the, you know, x distance and y distance, right? So, and how we're gonna pick, right? So maybe we're gonna pick, you know, the biggest distance, or maybe any distance. It doesn't really matter, right? It doesn't really matter how exactly we move towards this point, right? Going down and left, or maybe left and down, right? It doesn't really matter in which order we're gonna do all of that, so it doesn't really matter, right? But in any case, we need to know the delta x and delta y, right? So we're gonna say something like goal x minus me x, so this is delta x, and goal y minus me y, right? So we have delta x and delta y. Right, and I suppose what we're going to be doing, my friend, what we're going to be doing if delta x is greater than 0. Actually, this thing can be negative, so I suppose we have to consider the absolute value of this entire thing, right? So we have to consider the absolute value of this entire thing. If this thing is greater than 0, that means we have to move left or right. We have to move left or right depending on whether this thing is negative or not. So we probably don't want to do ABS in here, right? Because we're kind of losing the sign, right? This sign is kind of important. So we probably want to do math ABS in here, right? So because in here, depending on whether dx is greater than 0 or you know, less than 0, whether it's positive or negative, we're going to be moving in different directions. Right, so let's actually think about it a little bit. So if your goal is here, right, and u is here, so goal is bigger, the goal is bigger and u is smaller. You subtract a goal from u, you get a positive number. So that means if dx is positive, you want to move to the right. Okay, that makes sense to me, right? So you want to move to the right, direction is going to be right, and you start moving. So this is something like that. If this thing is negative, you want to move to the left. Well, I mean, it's not start, it's true. There we go. Something like that. Right. And we need to do this kind of shit now for y. Right, so essentially, if dx is equal to 0, and the question is it always going to be equal to 0? Because we're talking about, you know, floating point and scheiße. We're talking about floating point. We probably, yeah. So people are talking, we probably want to have some sort of an epsilon. Right, so we probably want to have some sort of an epsilon, and let's actually set some sort of an epsilon to 1 millionth. Why not? Right, I don't fucking know. So just something. We can always, you know, adjust this thing. Okay, anyway. So direct, well, what the fuck is this? So right, left. Okay, so everything's fine. So otherwise, if math obs dy is greater than epsilon, I forgot a very important thing. So we start moving, right? But now we also need to set the timeout, right? So the timeout before turn is essentially, as I already said, the absolute value of dx, the distance, divided by the velocity, and this is how you get the time, right? The basic math, the school math, the school physics, rather. The school physics. Okay, so this is common, and so the player speed, violence, momentum. Okay, so now we have this kind of thing, and obviously the vertical thing is symmetrical, right? So that means we can like literally copy paste this entire thing, and the only thing we have to change is the, you know, the axis, right? So now instead of dx, we have to do dy, right? So dx, dy, boom, cool. And now, okay, so if you are, the goal is lower, so if it's positive, you have to go down, right? And the opposite is up. All right, I think that's what we want to do in here. I think that's what we want to do in here. And at some point, right, if neither of those things are true, that means we reached the goal, right? So essentially we checked this condition, it was false. We checked this condition, it was false. That means we reached the goal. So in that case, we can just safely say that timeout before turn is undefined. Or maybe we can do something else, right? So essentially we can clean up this thing, and if neither of the branches ever executed, it's gonna stay undefined, so we know that we reached the goal. Something like this. So yeah, and once we joined for the first time and received hello, we are gonna just calculate the next turn, right? So here's the next turn, and there you go. So once we're simulating everything, what we can do, if timeout before turn is not equal to undefined, that means we're moving somewhere. What we're going to do in here, we're going to subtract the delta time, right? So we're subtracting the delta time. And if timeout before turn is less or equal than 0, the time has come for another turn. So I think that's the way to go in here. Does it even compile? I think it compiles, right? So, all right. So, and we're going to be basically just like, yeah. So at any point, we're going to just like stop and then consider the environment and just like decide where we're going to be moving and stuff like that. Do each bot needs to be aware of the other bots? Not right now. I didn't think so, right? So we just want to have some sort of a traffic. Right, so we just want to have some sort of a traffic, and we'll see how it's going to go, right? So because we need to make some sort of measurements. All right, so let me see. Okay, so I can move around, and I'm going to start le bot. I think it overshoots a little bit. This is so fucking funny. It always does that. I feel like it overshoots a little bit. Okay, so let me see what we can do in here. So is that because of the epsilon? Let's make the epsilon a little bit smaller. All right. So yeah, it doesn't help. Well, I mean, it's actually very small epsilon. The player moves very fast, right? So there should be more epsilon. I think the epsilon should be bigger. Yeah, I think it has to be much bigger. Yeah, okay. All right. Not bad. It even makes several turns because it overshoots. Look at that. So, yo, this is so fucking cool. Since it overshoots, the entire algorithm still accommodates for overshooting, so it goes in spiral. Holy sh! This... Wow! This is a very cool emergent behavior that I didn't expect, actually. I was expecting that it's always gonna do one turn, but since it moves too fast and there's a latency between the servers, it always overshoots, but the algorithm is robust enough to actually accommodate for that, and because of that it just moves in spirals. Yo, what the fuck? Like, why is it so fascinating? I fucking love that. It also waits a little bit before it does the thing. That was funny. That's actually funny. Emergent behavior, yeah, actually emergent fucking behavior. Okay, so let's see what we can do in here. One of the things I want you to do is, okay, if we reached the goal, we want to generate a new goal. We want to try to generate a new goal. You know how? You know how? I think I'm gonna put this entire thing into do while block. Right. And essentially, if after the iteration, after a single iteration, while this thing is equal to undefined, I want to try again, but with a new goal, which is going to be goal x equal to math random multiplied by common world width, and this is going to be y, and this is going to be height. People keep asking, why do you need like a loops with post conditions? You don't really need them, honestly. Like in the modern world, like you can always rewrite loops with post condition with like preconditions, but they're really good at retrying operation. So essentially, you in the body of the loop, you have an operation that may fail, and you want to retry that again. And this is what they're good for. Right, so you try it once, if it didn't fail, fine, it will never repeat. But then at the end, you realize that, okay, it failed. You want to retry with new parameters. It doesn't really accommodate this kind of thing. It would be kind of cool if this kind of operation was also part of this thing, but it is what it is, right? So, and again, it's not necessary, right? It's absolutely not necessary. You can always rewrite it with like a precondition, but if you have loops with post condition, they're kind of useful for these kind of things, right? They're kind of useful for these kind of things. So, and in here, right, so yeah, this one is undefined, right, and we either assign that and assign that. So something like this, right? Just try again, and let's see what is going to happen. Okay. This motherfucker's just wandering around. Look at that. It actually went diagonally? Like, what the fuck? How did it went diagonally? What the fuck? Honestly, we could have just always picked a random direction and moved there for some period of time, and that would have resulted in pretty much the same behavior. Though it's moving around in spirals like that is kind of cool. So maybe I'm gonna leave that. It's alive. Yeah, it is in fact alive, right? So I can create another one. There's now 2 of them. And they're moving around like just like trying to annoy me. And I can move around along with them, right? So because I can control this kind of stuff. So yep. So I wonder, like creating an entire, you know, instance of node for each bot is kind of an overkill. I want to be able to create several bots within a single node instance, if you know what I'm talking about. Just like open several connections. Why can't you open several connections? I think you should be able to open several connections. I mean, it's not that difficult to do. So let's actually see what we can do about that. So effectively, what we have in here, chat, what we have in here, we have a state of a single bot. If you think about it, it's just basically a state of a single bot. So we can optimize that state a little bit, maybe, by not having players. So maybe we don't give a shit about other players. So that's one thing we want to do. So let's give it a try. So if I remove the players and go to the fly check mode, so fly check mode is disabled, and I'm gonna go to the next error, fly check next error, right? So we're never gonna just set this entire thing, and when we receive messages about new players, whether somebody left or yeah, well, we just don't care about messages that we receive after we connect it, right? So we can just remove this entire branch entirely, right? And then when we're simulating the players, we're gonna only simulate ourselves. So essentially, I'm gonna just do me, and me, by the way, has to be defined, right? So not undefined, like this. And it can be undefined when we have not received the hello yet. When we receive hello, along with the hello, we receive the entirety of the state of the player, right? So that's basically what's going on here. Yep. I think there's another thing I want to do in here. To do the proper simulation, I need to also do these kind of things. Right, so this is the direction, right? And this one is true, right? So this is true. And this is going to be left, and this is also true. Right, since I'm not handling the events that we receive from the server, right, I will never actually update any of my moving bits. Right, so because I used to update them through receiving events about myself. Now I don't really care about events of other players, so now I kind of have to update my own state myself, right? So this is kind of dangerous, honestly. This is kind of dangerous because that means I won't synchronize myself properly. So I suppose I still need to handle, you know, events like, you know, I'm moving, but only when I'm moving. Right, so let's actually do the following thing. I parse the message, and then I check common is player moving, right? Is player moving? So this is the message. If this is the message and the message ID is equal to me ID, and we know that me is defined because we already checked for that, only then we're going to be updating this stuff, right? So player moving contains a lot of useful stuff like X and Y and start and direction and everything. So yeah, this is where we can do this kind of stuff. All right, so X, message X, Y, and me moving, message direction, message start. So we're handling only one kind of message, but only if the ID is us. We don't really care about anyone else. Right. So we really don't care about anyone else. I think that's a good way to approach this in testing. I think that's a good way to approach this in testing. We're only simulating ourselves. So let me see if I didn't break anything. Everything seems to be working. So now if I run another bot mgs, yeah, there's a second one. Okay, so it's cool. I didn't break anything. So yeah, here we have a state of a single bot. A state of a single bot. We can factor out this entire state into a separate interface, into a separate object, right? So that's one of the things we can do. So let's create interface bot, and that thing is going to contain all of these things in here, right? So it's a, you know, so now we'll be able to create copies of the states in here. So this one is WebSocket, right? So then we have me, which is a player or undefined. So here are the goal. And all of that is probably going to be just a number, right? So number, and this one time before turn is basically undefined or number. Since we always generate time before turn, maybe it doesn't make any sense to make it undefined, but it being undefined is very useful to retry things, right? So because of that, I think I'm going to keep it as undefined. Right, so we have a bot interface. Now we can maybe factor out this thing into like a function create bot, right? So, and this is going to return bot. And effectively in here, we can just do const bot, just move it like that, something like this, right? So in here, we can try to do it like that. So this is new thing. It will always create a new connection. Me is undefined for now. So goal, originally goal is going to be at the center of the screen. Do I want to use a random one? Nah, let's keep it like that. And this one is going to be originally also undefined, like so. So here is the bot, and here we're going to be returning the bot. Right, and essentially, so we have functions like turn. I think we can basically now accept the bot as a parameter. So the bot used to be a global data. It used to be a global data, but now we're going to have several bots. So that means function turn must work with any bot. So when we parameterize this function with the bot we want to modify. So, but all of these things that became global, they need to be prefixed with the bot. So maybe let's go ahead and just query replace me with bot.me. All right, so, oh shit, right. Okay, so that's a little bit different. Can I do some shit like query replace by regular expression, but use like a boundary, word boundary shit? I think I can. Yeah, look at that, look at that. Can your Vim do that? Can your Vim do that? Right, so, and the next thing is going to be, I suppose, WS, WS, right, so this is that. So now all of that is prefixed with this kind of stuff. And right, so let me see. So could replace this thing with bot timeout before turn. This is another one. I know this fucking itching, mate. Goal X is bot goal X. Right, so it's kind of an interesting sort of refactoring. The code used to be like a single bot code, but now we are scaling up that code. We're scaling up that code. And the interesting property about such language as Jai is that it makes it easy to scale up code. In the sense that, look, here, like I used to work with a single bot and the state of the bot were just global variables, and it was fine. But now I may have different kind of bots, so that means I have to specify which exactly bot I'm talking about, and now I have to prefix this kind of stuff, and it's not particularly convenient and everything. So one of the cool things that makes Jai easy to use in this kind of situation is the using word. For example, in Jai, I could have done something like using bot, and I would never have to add any of the prefixes in here. I would have used like the same code. And this is kind of possible to do in C++, right? So it is possible to do in C++ if you just make it method, right? So you also don't have to prefix anything. And I think in JavaScript there was a with keyword at some point, but it was very much discouraged and I think even removed at some point. Does anybody remember the with keyword in JavaScript? I think it was a thing at some point, but then it didn't really work out for whatever fucking reason. Destructure, maybe destructure could actually work in here, right? So JavaScript with, do people still use it? That would have been actually convenient. So can I use a dark theme? Thank you very much. So with keyword, we don't even have to read any further. It's deprecated, so who fucking cares? So the with statement extends the scope chain for the statement. Expression adds the given expression to the scope chain. Blah blah blah. Yeah, okay, I see. Whatever. I think it's kind of similar to the one in Pascal, right? So with it and safe, yeah. So I suppose it doesn't really play super well with the craziness of the scopes of JavaScript, right? So because I can imagine, right, especially with like how this is bound and everything, I suppose with could be like very much unsafe to use. It works out in Pascal because Pascal is a simpler language, right? And in a Pascal, in an original Pascal, right? I'm not talking about objective Pascal or like Delphi or anything like that. In original Pascal, there were only structs, so you could just like export fields of the structs. And since it's just that, so there is no anything particularly unsafe about that. So it worked out for Pascal because it's a simple language. For more complex languages, yeah, you may have very undesirable emergent effects. So I can actually see that. So yeah, anyway. It is what it is and it isn't what it isn't. So what other problems we have in here? So let's go into the next error. So here is the, okay, so here we are initializing the socket. I suppose maybe the socket initialization could have been done somewhere here. Yeah, so essentially let's create a bot and instantly initialize its socket, right? So we'll have to replace its WS. All right, so this is that. And here, as you can see, we use turn and we have to pass bot in there. So what else do we have in here? So we have me. Let me try to replace me as well. Boom, 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 boom. I want you in my room. Let's spend the night together. Together in my room. Right, this one is rather interesting. So we have tick. Do we want to also put it inside of the of the create? What is it going to work even? So nah. Well, I mean, essentially you can query replace timeout. What was that? Timeout. Yeah, and now bot, and this one is bot. Is that a good idea? It's kind of weird. But I mean, it compiles. So, and essentially, I suppose we want to have something like bots, which is an array of bots, right? So this is an array of bots. And maybe we want to just push a couple of the bots in there. Let's actually just like, you know, do something like this. Bots push create the bot. Does it compile? Motherfucker compile, okay. So we can probably move this entire thing here as well. I mean, so wait. What if we just do something like that? We don't do this parameter. We don't have to, yeah, because this bot is within the scope. This is an old school class, isn't it? This is an old school JavaScript class because this is how they used to work, I think. I think this is how they used to work. So what do we have in here? Like 41 and yeah, this motherfucker compiles, right? So yeah, it's a vanilla class. I accidentally recreated a vanilla class. So I mean, the new ES6 classes suck ass anyway, so who fucking cares? Like, it's vanilla classes all the way through, right? That's the proper Java. This is how JavaScript was designed. This is how it was intended, right? So they created ES6 classes for these Java plebs, right? So because they had a pool of enterprise developers, so they needed to migrate those enterprise developers to web. And since the old dogs can not learn new tricks, they had to create these classes so it looks like Java. So yeah. I don't know actual reason, right? But I mean, it kind of makes sense to me, right? So why the fuck else would you introduce these stupid ES6 classes if not to make JavaScript look like Java? Now it's literally JavaScript. If you think about it. It is really. Honestly, the real JavaScript is probably Groovy. Do you guys know what's Groovy? You guys know what is Groovy? Does anybody remember Groovy? It's such a fucking old project. Does anybody even use it? Apache, yeah, that's how you know the project is dead. Anyway, so it's basically an interpreted JVM language. So this is like an OG JavaScript. OG JavaScript. Why is it called JavaScript? Because Java was popular at the time. So that's literally the reason, seriously. It's just like, this is a purely marketing thing. This is purely marketing thing. When JavaScript was created, they needed a way to promote this shit. So they just included a buzzword, a trendy buzzword at the time into the name. And that's how JavaScript was born. So Java is not as trendy anymore, but the name kind of persisted. So that's basically how it works. Marketing joke, yeah, I suppose. So they were not even allowed to officially call JavaScript. It was not even officially called JavaScript, right? So because they had problems with, you know, the trademarking with Sun Microsystems, right? So I think at the time Sun actually owned Java. So they couldn't officially call it JavaScript because Sun would fucking, you know, destroy the ass for that. So it was kind of an official name, but the official one was Emacs script, or yeah, ECMAScript. Emacs script. So they called it Emacs script. So yeah. Emacs script. So that's the story. That's the story. You are all too young to remember this shit. You are all too young. Yeah, there we go. It works. So now I can scale the amount of bots. So what if I create 10 of them? It says to lag a little bit, honestly, but it works. What about 20 of them? What about 20? Right, that's pretty funny. I wonder if this is because of the logging. So let me actually disable the logging for the server. So console. So specifically received the messages, right? So where is received the messages? This is the server. Right. So received bogus amogus. Received the ammo moving. Okay. So let me restart the server. So that kind of killed this client. So let me refresh this thing a little bit. So okay, now if I just try to do that, nah, it's still kind of laggy buggy, but that's good. Honestly, that's good that it lags. So now we can pinpoint the problems with this entire thing. Right, so which is good, but with the amount of bots like 2 or 3, let's actually start with 3. I think it's fine. This seems to be working fine. All right. So we can now try to collect some statistics on the server, right? So we can just basically spawn like 20 bots and then measure how many packets we receive per tick, how many we process per tick, how many we sent out. I would also like to, I think I didn't mention that at the beginning, I would also like to measure the amount of bytes, right? Because before sending out shit, we converting all of that thing into string, right? So we stringifying. We can always just take the size of that string and also collect information like how many bytes we generated with all of that, right? Because if we're going to be justifying introducing like a binary protocol, it would be nice to just like, you know, measure how many bytes we saved from doing that. So maybe too much data from the socket, yeah, probably. And what's interesting is that, so there's also a problem with the clients, is that we kind of handle message one by one, right? So as you can see here, there is an event listener. We receive one message like player joined, and the next player joined is received on the next call of the callback. What if we have like a 10 players, right, that, you know, just joined? So for each player, we're gonna call a separate callback. Can we, for example, like, you know, batch all of these things into a single thing and just process it in a single callback? I think that will be actually faster, maybe. I don't know. I'm not a web developer. So we have like 1,000 poorly batched events. Who remembers this shit? Like 1,000 poorly batched RPCs. It's just like, who's? I think it was Elon Musk. I think it was about the Twitter, right? So it's just like, wait. I don't remember that. Wait. So Elon Musk 1,000 poorly batched something. I don't remember. Yeah, so by the way, I'd like to apologize for Twitter being super slow in many countries. App is doing more than 1,000 poorly batched RPCs just to render a home timeline. So, and this thing became sort of a meme at the time. It was in 2022. Holy shit, it was already 2 years ago. Damn. So yeah, what we're doing, we're poorly batching the events. So maybe we should batch them less poorly. That's basically the idea. But I'm already streaming more than an hour, and you know what that means, chat. You fucking know what that means. That means the time has come for a small break. And after the break, we're going to integrate the statistics to the server. And we're going to spawn a bunch of bots. We're going to collect some statistics, and we're going to make some conclusions. Maybe the ones that we won't like. But that's fine. We're doing science. So yeah, let's make some break and okay, so let's go ahead and integrate some statistics to the server, right? So how are we going to be doing that? I suppose we're going to be just creating an interface which is called, you know, interface stats, right? So, and this is where we're going to keep all of our precious stats. So let's actually go to the stats.txt, and yeah, so what kind of, this is basically the stuff that I want to measure. That's a lot of stuff, but actually not that much. 14, only 14. So average time to process a tick, right? So how we gonna call that? Average time to process tick. I'm not particularly creative when it comes to the names of the fields, right? So maybe average process tick, average tick time. I just had to iterate on it a couple of times, right? So we're gonna start with the average tick time. So this is the average tick time. So this is where we do the tick, right? And essentially how we can do that. So I know there is a performance thingy, right? So performance thingy majingy. And within the performance, we have things like now. The future is now, old man. So, and we have a DOM high res timestamp. DOM high res timestamp, but it doesn't really say what exactly it is. So what the fuck is a DOM high res timestamp? So how high of a res is it? So let's actually take a look. So method returns high resolution timestamp in milliseconds. How milliseconds is a high resolution? Can anybody tell me? Oh, maybe it has a fractional part. Is that what it means? It means it has a so can anybody explain me what's up with web devs and obsession with milliseconds? Everybody in the computer graphics world uses seconds with fractional parts. So because it's easy to do things per second. So, but web devs, something is wrong with, like, they obsessed with milliseconds. So because they love MS. It's like a reverse of okay, so a lot of interesting hypotheses. Thank you so much. all right, whatever. So performance now. So begin MS. Okay, so here we are processing the events, right? So we're shuffling the events. So, and then we clean up the event queue. Then we simulate the players, right? So we simulate the players. And this is where we're probably going to do something like begin MS, and we're going to just do performance now minus the begin MS, right? So, and this is basically the thing. Right, so tick time, we're gonna call it tick time. So this is the tick time. But here we wanna have like an average tick time. So that means we need to have some sort of a buffer. Yeah. So I suppose we have to keep track of tick times, which is gonna be an array of these motherflippers. Ha. Know what I'm talking about? You know what I'm talking about? That's what we need to do in here. So it's a tick times, and we essentially going to be just appending those things in there. Right, so we need to have an instance of stats, by the way, right? So essentially this is going to be global stats, right, which is the type of stats. And it's a little bit of a redundancy, right? So maybe it doesn't really make any sense to have this interface at all. So just have it as a global variable. But I feel like maybe I'm going to be passing it around to different things, but not right now. If I'm going to start passing this thing around, I'm going to factor it out into a separate interface. Let's not jump ahead of ourselves, right? So we're going to just say that this is just that. I can always do something like this. Can I? I think I can. Do I have a fly check mode enabled? Fly check mode enabled. So it doesn't like something about this kind of shit. So you can't. Oh yeah. So you have to do something like this. Damn, it cannot. How can I define an object and simultaneously kind of indicate the type of this thing? Do I have to do as array number? Do I really have to do shit like that? Is that normal in TypeScript? Does anybody know? Like I just don't want to create a separate interface stats. I mean, I could. But it's kind of, so yeah, it's tick times number. But I mean, it didn't work. Chat, listen, when I did something like that, you obviously don't watch what I'm doing. Look. I did it like that. It doesn't like it. People who don't know TypeScript are trying to give advices again. Okay, I'm gonna ignore the chat. People, you're funny. You're funny. You're being funny again. Don't be funny. Don't be silly. Don't be silly gooses. On the looses. Don't be like that, please. Don't be like that. Thank you very much. Anyways, so alright, so we have a tick time, and essentially in the stats we're gonna have tick times, and we're gonna push this mother flipper in there. Look at that. So we're pushing that tick time into here, but here is an interesting thing. So if we like have too many of them, so we need to decide how many of the tick times we're gonna have in there. So how many of them? So let's say that we're gonna have them as many as we have FPSs, right? Or maybe we're gonna introduce something like a stat average capacity, right? So I'm gonna say that for things that we're computing averages for, the capacity is gonna be this, right? So what that means essentially, that means that if stats tick times length became bigger than stats average capacity, we have to remove the first thing. And if I remember correctly, somebody submitted that as a PR to client. You just do shift, right? And shift removes the first element from the array and returns it. And if the array is empty and defined, blah blah blah. So there we go. It just removes it from the from left, right? So this is basically what we have in here, right? So so I would personally maybe call this not begin a mass, but begin tick time. Begin tick time, right? So begin ms, begin tick time. And as you can see, we're basically accumulating a buffer of tick times, and then we're gonna print the average of them. So how are we gonna be printing the stats? How are we gonna be doing all of that? This is a really interesting question. Like, how? We can just accumulate this kind of thing, and maybe we can you know, send it at request. The most logical thing to send it would be over HTTP, but unfortunately our server doesn't have HTTP yet. Right, so maybe we're gonna just print the stats periodically. So essentially, maybe we need to have some sort of function. Let's call it function print stats. Right, so print stats, and here we're gonna just print the stats. So let me try to do that. If I take the stats, and can I sum them up? Do I have something like sum, or do I have to use reduce? Right, I think this is what I have to do. So call the specified callback for elements. So previous value, so current value and current index. So essentially in here I can do a, b, so a plus b. So, and that's how we do that. The return value of the callback is the accumulated result in the provided argument. Do you provide the initial? Yeah, you can provide the initial value, but it's kind of like optional thing. It's kind of an optional thing, but we can do that. So this is going to be 0. So this is basically tick times sum, right? So this is a tick times sum. And at the same time, it doesn't really matter. We can just right away do stats tick time length. Right, there we go. And we can just print that. So let's say stats, right? So this is the stats, console log, and in here we have average. So let me actually literally go here, average time to process a tick. Average time to process a tick. Maybe we're gonna even indent this entire stuff a little bit, and I think we're Gucci. We are in fact Tamaguchi. All right, so, and we can maybe print that every second, maybe, right? Maybe we're gonna print that every second. So, but to print that every second, maybe we need to keep track of the ticks, if you know what I'm talking about, right? So ticks count, right? So ticks count, and it's originally gonna be number. Right, so, and in here ticks count is going to be 0. So, and essentially the idea is stats ticks count, I'm going to just do +1. So this is how many ticks so far we've got. And if stats ticks count is like a mod, so every second is basically server FPS, right? So this kind of something like this is equal to 0. We're going to do print stats, right? So that's basically what we're doing. We're printing the stats. Okay, so the server seems to be working. So let's actually restart the server. Right. Okay. So average time to process a tick. That's actually pretty cool. So, all right. We can also introduce something like console log ticks count, and this is going to be stats ticks count. I think it's also a very useful information. So as of right now, it's pretty fast, right? So it's pretty fast. As you can see, like a ticks count like grows. Right. So okay, so we're starting to get some interesting statistics, and now I can try to join the entire thing. And now the amount of time to process a tick actually grew, right? So because we have players and stuff like that. But if I close that, it drops, and yeah, because we don't have to handle shit. Okay, so that's already very useful information. I think that's a very useful information. Yeah, look at that. That's pretty cool. So average time to process a tick. So if I introduce more things, right, something like this, and this is going to be localhost 6969. So now we have more of this stuff. Yeah, it's growing, and I would say it's already more than the FPS, more than 30 FPS, honestly. All right, so if you think about that, because if you like divide 1 over 30, it's supposed to be 33 milliseconds, but that's already more than that. But average time to process a tick, I think it's... Wait, these are milliseconds, aren't they? These are milliseconds, so that means it's super fast, actually. Yeah, this is not seconds. Yeah, the web devs debated me again, right? I thought this is seconds, but this is actually milliseconds, right? Oh, right, so maybe I have to explicitly say that this is in milliseconds, but yeah. Anyways, so let's actually collect some other statistics, right? So total messages sent times 60. It was 0.30 seconds, but this is not seconds. Again, this is milliseconds, right? So tick time is actually milliseconds. So that means, right, if this is a milliseconds, that means I need to divide it by 1,000, and only then it's going to be accurate. Right, so let's actually give it a try. Right, so if I try to run it now. Yeah, so this is the actual performance over tick. This is how quickly, like actually quickly we're doing that. So if we join, it's still within 30 FPS, so it's totally fine. Right, it's totally fine. We can actually run a bunch of bots at this thing. So let's actually run the bots and see. So there's only 3 bots. Yeah, 3 bots don't do anything. They don't do shit. So let's go into the bots MTS, and let's say we're gonna have 20 bots. The 20 bots is where the shit at. Let's go. Oh, fuck. Well, yeah, that's already caps the performance. Yeah, that's already caps the performance. It's already stats lagging. It's already stats lagging. So it's when you have 20 of them, right? So when you have 20 of them, that's already stats lagging, which is which is exactly the information that we need in here. Right. So that's precisely what I want to see. Yeah, that's cool. That's very cool. So then we're gonna disconnect them, and now it's super fast again. Right. So that's very cool. That's very cool. All right. So what are the other information we care about? Total messages sent. Okay. So how are we gonna be even doing that? I think we send messages only over send message method. So there is a very interesting method called send message, right? And it doesn't really do anything except accepts the socket over which you want to send something, and message, which is usually an object. And what it does, it just stringifies that object and send it to the socket. It feels kind of useless, but the only purpose of this function is to enforce a particular type of the message. Right, it's the only purpose of this thing. So essentially, if I ever modify and add new field in here, like foo, I want the TypeScript compiler to tell me that this particular place, right, this particular place is broken now, and I need to add this field in here. Right. So I tried to find a different way to enforce this sort of like typing, and I couldn't do that, except maybe creating a separate variable, but I may forget to create a separate variable, so it's totally fine. All right. So that's the purpose of this function, is to enforce a certain type that I put in here. Right? Does it make sense? I hope it makes sense. Right. So, and essentially what I'm thinking is that maybe we're going to be collecting the statistics through this function. Right, so maybe we're going to be doing it like that, or maybe I'm going to just like literally go through every send message and just increment. Right, so maybe that's what I want to do. I don't fucking know. So total messages sent. Right, so we can do that. So stats total messages sent number, total messages received. Maybe we don't even have to call it total. We can just call it you know, messages sent, messages received. It doesn't have to be total. This one is 0. All right, and in here we're gonna have console log total messages sent stats messages. Thank you so much, Mechanic World, 41 subscription. Thank you. So messages sent, messages. Did I spell received correctly? I think I spelled received correctly, or maybe it's received. Yeah, I can never remember in which order you put I and E, honestly. Yeah, so it's kind of difficult for me. I don't speak English at all. Isn't there an Emacs magic to increment total messages sent? What? I don't know what you're talking about. We're incrementing in JavaScript code. What? I don't understand. Anyway, so total messages sent, total messages received. So it would be kind of cool to just do that within send message. But send message is used not only on the server, it's also used on the client. So, and the clients don't have these stats, right? So it doesn't make sense to embed that into the send message. I can essentially go and send message. Every time I do send message, I can do something like stats messages sent +1. And I probably have to do that on each send message. But then, okay, it's tedious, first of all. It is in fact tedious. And second of all, I may forget at some point to do that. So it would be better to actually do that within send message, honestly, somehow. It would be better to do it like that. But how can we do that? I don't freaking know. On top of that, I also need to have average messages sent. Track sent messages at in direction. So interestingly, we can essentially in a common MTS simply accept. If I could, I can't even pass a primitive type by reference in JavaScript. I can't even pass a primitive type by reference. Create a function wrapper and server MTS. A function wrapper. I guess that's one thing I can do, but it's kind of lame. So what's funny is that I also need to collect another statistics, which is how many messages I sent within a single tick. So I may have a variable that locally keeps track of how many messages I sent within a single tick. Then that variable is going to be appended to the list of like these kind of things, right? So where we compute the average of of messages sent per tick, and then it's going to be appended to the message totally sent, right? To the message totally sent. So something like that, something like that. So, and we can have some sort of like a message counter, right? Which is going to be count number, right? So this is a message counter, and in here we can essentially do counter, message counter, right? So this is a message counter, but it could be missing. You know what I'm talking about? You know what I'm talking about? Yeah. So, and essentially, if counter is not equal to null, counter count plus 1. Right. So that's kind of interesting. Kind of interesting. Yeah. So this is the kind of counter. And where do we send? Do we send the messages outside of the tick? I don't think so. Oh yeah, so we don't send the messages outside of any of these things. Outside of any of these things. So now, here we have begin tick time, and then we can do something like message counter, which is going to be count 0, right? It's a very long name. It's a very long name, but maybe let's call it maybe count. Well, whatever. Send message, and I wonder if I can maybe record a macro. Send message, then something like this. Message counter, and then F4. Boom, 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 boom. Oh shit. But anyway, all right. So let's take a look at the errors. Right? Do we even have an errors? I don't think so. But yeah, fly check next error. Yeah, there's no errors. Surprisingly. So let's disable the stats. Let's disable the stats and restart the whole thing. Does it compile? It's taking some time to compile. Like, what is it waiting for? Okay, finally. So, and it doesn't compile, right? So this thing was actually lying to me. This motherfucker was lying to me. So next error. Yeah, so there's that. It tells me that there's everything's fine. Oh my god. So 143. I see. So it says send message. But didn't I like why do you tell me that this thing expects 2 arguments but got 3 when this is an optional argument? I don't understand. Isn't it like can I do it like that then? I could swear, dude. Oh, okay, it's in a bot. Okay. Fine. All right, so I can put it like that. Bruh. Okay, so 158. Message counter count is possibly how is it possibly undefined, bruh? So here is the message counter interface. Here's the message counter interface. What? Not equal null, or is it not equal undefined? It's undefined. I completely forgot that in Java. Like, okay, why the fuck JavaScript has 2 nulls effectively? Because undefined is effectively a second null, isn't it? Right. And on top of that, they have 3rd kind of null, which is an empty element of array or something. What the fuck is wrong with the designers of JavaScript? It was designed initially kind of poorly, but the current designers of JavaScript keep doubling down on poor design. It's not like they're fixing anything. They're just like doubling down, really. They're really doubling down on the poor design. And it's just like, what the fuck is wrong with you? Just fix the problems already. So, anyways, what do we have? So this is a message counter. And essentially, so this is the messages sent, and this is literally what we can do. So stats messages sent. We're gonna add counter count, and so it's a message counter. All right, there we go. It's pretty cool. And now messages sent. So maybe I'm going to do the following thing, chat. I'm going to do something like that. So we done with that. So messages sent, we have that. Total messages received, we don't have that. So, but maybe we can do that because it's actually easier. Counting the received messages is much easier because we can do that in here. So we can do stats, messages received +1. So that's it. So every time we receive a message, that's +1. So that's basically it. That is basically it. So total messages received. So this is basically, yeah. Average messages sent per tick. Okay. So messages sent, messages received, messages tick, messages sent. So, and this is array of numbers. So this is array of numbers. Tick messages received. And this is array of numbers. Okay. So, and let's also initialize all of that stuff in here. So, and this is empty array. Right, so this is an empty array. And this is another empty array. Cool. So do we have some sort of a function called average? You know what I'm talking about? Something like function average, which just accepts an array of numbers and returns a number. And what it literally does, it does that. So we just do that and just return this entire thing. So this is going to be axis. There we go. So this is the length. And essentially, we just do average. Dude, I know what is undefined. I know that it's an absence of... Dude, listen. There is always an excuse for poor decision. Like, you can take any fucking language. You can take any poor decision, and you can always find an excuse. I know them all. There's no reason to tell me all of that, okay? It doesn't really change anything. You can justify literally anything. Okay. So, yeah, we added that thing, like the creator was just in a bad mood, right? Yeah, so it's fine. Anyways, whatever. So here's that. So this is the average. And so do we even have a function like that, right? So tick times received. So, and the reason why I want to do that is because we're going to be having these kind of things, right? So total messages sent, total messages received, average messages sent per tick. All right. Console log. Average messages sent per tick. All right, so it's gonna be average, average, and stats, tick messages sent, tick messages sent, received, tick messages received. There we go. So there's that. I would also like to factor out this kind of shit. So something like, I don't know, push average right? So, and essentially here we just like put that, but at the same time, internally it does that. So it just like simplifies our lives. So let's find the function average. Let's find the function average, and this is where we're going to do all that. Push average access array, array number, x number, right? And in here we're going to just do access x. Might even be a little bit cool like that. Look at that, look at that. So it has to be x. I wonder, does push return anything useful? So appends a new element at the end and returns a new length of the array. Yo, bruv. Look at that. Look how pretty this code. Look. Very concise, very expressive. Look at that shit. Look at that shit. Yo. Yo, yo, yo. So, and we don't even have to do this kind of shit anymore. Bruv, bruv, bruv. Telling you, bruv. Telling you, bruv. Okay, so this is basically like a tick count. So this is the tick time. I suppose we can even inline some of this stuff. I want it to be like just like a straightforward enumeration of the parameters we are incrementing like this. So first ticks count, then ticks time, messages sent, messages received is actually computed out in a different place, so it doesn't really matter. So here tick messages sent. All right, so tick messages sent, it's basically push average stats, and what we're pushing in here, we pushing the messages counter like so. So this is how many we received, but how many we actually, yeah, so this is how many we sent, but how many we received. The amount of things we received is actually the size of event queue. So that means chat, we have to maybe clean up the event queue after that. Yeah, so the amount of messages received, per tick is the event queue length. That's how we collect the stats. Right, so introduction of these push average functions is actually very useful, right? So it makes it more readable. So at the end of the tick, we're just incrementing these fields, right? So we're just incrementing these fields. Okay, makes sense. In the same order as they are defined in the interface, right? In the same order as they defined in the interface. Right? So, and do we print them in the print stats already? I think I already did. Yeah, so all that is printed already. So we're slowly establishing the framework for different stats in here, as you can see. We're slowly establishing a framework. Yeah, and I think collecting this kind of stuff is super important. They kind of remind me the stats that are collected in Memcached. Remember the Memcached stream chat? Remember the Memcached? So for those who've never seen it or don't remember, so I think I can find it on YouTube. I don't remember what was the name of this stream. Does anybody remember? I think it was something like the best coding interview question or something. So let me see. So the best interview question. Yeah, the best coding interview question. Right. So, and in that specific stream, we actually looked into the source code of Memcached. And one of the things that the source code had is a system that collects the stats. And I criticized that system a little bit for the fact that when you add a new stat, it's very difficult to update all of the places, right? So we should not fall into the same trap as the Memcached did, right? So we may actually, it's very easy to fall into that trap, but yeah, so I'll think how we can implement a system where if you add a new stat, so it should actually notify you, like show you all of the places where you have to make like updates and stuff like that. Right, it kind of reminds me of the Memcached system. So, and I think it's very important to have this kind of like stats, right? Just to troubleshoot different problems. Implementing income multiplication, yeah, exactly. Exactly. You already forgot to update message received. Messages received? No, I didn't. So here it is. All right, so let's actually take a look at all of that stuff. So we already enabled the stats, and let's go. Okay, so total messages sent, total messages received, and stuff like that. Actually, I can just start the bots and yeah. Messages sent per tick. Total messages received. Why don't we send any messages? So this is sus. See? Messages sent. So we only receive messages and we... Oh, yeah, this is actually very cool. Average messages received per tick. So that's how many of them we are handling. So there's definitely some problems in here with messages sent. That's kind of bizarre. Messages sent. So we're using message counter, right? And we're pasting message counter everywhere. So it's originally 0, and in send message, somebody lied to me. Is it undefined or is it rather null? So it doesn't increment this shit. You motherflippers lied to me. You literally I'm gonna ban somebody. I'm telling you, bro. I'm gonna ban somebody. I'm gonna literally ban. I'm gonna find who did that. Well, I probably need to do F counter. Yeah, I agree with that. This is probably what I need to do. All right. So let me actually log that. So it's gonna be counter, and let me maybe restart the whole thing. I probably won't be able to see anything. So no. It keeps incrementing and stuff. So you saw that, right? So look at that. It keeps incrementing at some point. Actually, it sends too much. I'm confused. I'm literally confused. I could do this kind of thing. Right, so let's actually do something like this instead. Maybe it really doesn't receive them, but it must receive them when they stop moving. So I don't know. I really don't know. So it literally tells me, so this is a sent messages, so it doesn't really send anything, but it keeps receiving messages. One more time. So messages received. Okay, it keeps receiving messages, but it never sends anything. So print stats receive. Okay, so tick messages received. So sent messages. Messages sent, messages counter, and the messages counter. What if I just print message counter in here, like after the stats, just to be able to see? It's always 0. Well, I mean, in that case, it's fine. It ends up being 0. It ends up being 0, so it never updates. But in the sent message, it was actually printing. It must be some stupid JavaScript shit. It must be some stupid JavaScript shit. I'm telling you, like I don't see any reason for this not to be like that. It must be some stupid JavaScript shit with objects and stuff like that, right? Because if I take a look at the just console log, right? So this is the counter, right? If I just print this entire thing, yeah, as you can see, counter was incrementing there. So it was incrementing there, but it was never this kind of thing. Is there a difference between less? Only in terms of assignment. Only in terms of assignment, so yeah. What are you suggesting, people? Counter would be false if it's 0, but I'm not checking counter. Counter is message. Okay, whatever. Royal Flush Guy, thank you so much for the sub. Hey Todding, how are you feeling? I hope you're well. I'm well. It's just like stupid JavaScript shit is ruining my development experience, but I mean that's kind of common thing in here, so nothing particularly special. So message sent counter is going to be 0. Okay, so let me go to the next error. Next, come on, you can do that. Why are you hanging? Why? Okay, thank you so much. Right, so message sent counter +1. Next error. Message sent counter +1. Next error. Message sent counter +1. It's not even that different, so I still have to not forget to do this kind of message sent counter +1, and yeah, message sent counter +1. Next error, yeah, message sent counter sent counter, and I suppose that should work, I think. But here we also have to make it let, otherwise it's not gonna work at all. So, and let's take a look at the next error. Okay, so everything's fine. Now if I try to do this kind of stuff, so it's 0, but now if I do this kind of stuff, now it's working. It was in fact some stupid JavaScript shit. We're not sending anything. I know why. Oh my god, I know why. Because there's some things that we send not through the send message. It's when we have an event that is already a string. All right, that's annoying. That is annoying, but it is what it is, and it isn't what it isn't. Okay, so let's actually find all of the sends, right? So this is one send, this is another send, this is another send, this is another send, this is another send. So this is the only send where we didn't increment, right? So message send counter +1. So another send. Okay, that send is fine. Right, so that send is fine, that send is fine, that send is fine, that send is fine. Okay, so I think that was the problem. It was not JavaScript chat, it was my chat actually. So everything's fine, chat, everything's fine. All right, so let's take a look. So average, oof, look at that. This is what I wanted to see. Average messages sent per tick, 200 of them. On each tick, we're sending out hundreds of messages. Just each tick, hundreds of messages. So that's a problem. That's a problem. We want to somehow reduce this amount. And this is only the amount of messages. This is only the amount of messages. We don't even count the bytes or anything like that. Right, so that would be interesting to actually like count bytes and shit. Only 20 players, yeah. So what I'm thinking is that, well, I mean, yeah. So batching them up would have been actually very useful. Right. Batching them up would be very useful. Okay, so what's the next stats we would like to take a look at? So stats txt. So this is average. Yeah, total bytes sent. Total bytes sent. So let's go ahead and do that. Bytes sent. Number. Bytes received. Let's go. So let's also bring that. Console log. Total bytes sent, which is stats, bytes sent, and the bytes received. Received. Cool. So message sent counter. So it's actually very easy to find all the places where we sent in the messages. We could actually return the amount of bytes in this function. So, so text, and I'm gonna basically assume that the amount of bytes is the length because we're not sending non-ASCII stuff. Right, so let me see text, and I suppose it's a basically length. Does it have like a length in bytes or something? So bytes, byte length, maybe it has byte length, byte, no, it doesn't. So, but again, so in that JSON, we don't really have, you know, non-ASCII stuff, right? So we can just assume that the length is equal to the amount of bytes we sent. So that's totally fine. That is totally fine. That is totally fine. So message send counter bytes. We need to introduce bytes send counter. Bytes send counter, and it's gonna be 0. So message send counter bytes send counter ++1. So message send counter. So this is that one, and this is another one. So bytes send counter. So this is another bytes send counter. Bytes send counter ++1. So this is that one. Bytes send counter. Another one. Send counter. Another one. Ooh, this one is interesting. Well, this one is very easy. Bytes send counter plus event string length. Thank you. Okay, so that's it, I suppose. That's it. So, and because of that, so we can do stats bytes send plus bytes send counter. Like this. Bytes received is rather interesting. So let's find where we do the message. I think it's, yeah. So stats bytes received plus event. Oh, since it's an event data, can I do something like a byte? Well, I mean, I probably have to do to string and length. Yeah. So this is how we're going to be doing all that. But we also need to compute average bytes sent per tick and average bytes received per tick. This is another thing that we need to have in here. We can easily do that as well. Tick bytes sent, which is array number, tick bytes received. All right. So bytes sent, bytes received, we didn't initialize those things, so this is just zeros, and we can do something like that. All right. So bytes sent, bytes received, and average bytes sent, average bytes received. So that's understandable. Oh, this one is going to be rather interesting. Like average bytes received is kind of difficult to measure, but I will try. Come on, align already, Emacs, just align. Thank you very much. Okay, so stats tick bytes sent. All right, so and this is basically the average that we want to have in here, and stats tick bytes received, which is average. Okay, so that's cool. That is very, very cool. So bytes received, so this is a byte counter, but another thing we can do is to push average stats tick bytes sent, bytes sent counter. Cool. But how do we know how many bytes we received in here? We already have everything pre-parsed. We already have everything pre-parsed. So yeah, when we're pushing event queue, in the event we don't know the size of the event. That's kind of the problem. That's kind of the problem that we have here. We need to store it somewhere. We can store it along with events, but that's annoying. That is insanely annoying, because like where are all of the places? Like let's take a look at the amount of errors that we introduce. Yeah, so you have to now push oof, yeah, that is actually annoying, but it is not as annoying as I think it is, because we can employ a similar technique. So you see, we have this global variable, and within a single tick, it accumulates all of the events you receive until the tick function fires up, and then that tick function cleans up this entire stuff. We can introduce bytes received per tick, maybe within tick, which is initially 0. And look, in here, we kind of do this thing, right? And then we're gonna push average stats tick byte received, bytes received within tick, and we're gonna clean up this thing at the end of the tick. That is it. All right, so let me take a look at the order of these parameters. I just want to make sure that they make sense. So byte sent by received is located in a different place. Sent received. Okay, so that's pretty cool. So I think we're collecting here all of the necessary information. Average bytes sent per tick, average byte received. So let's take a look at the errors, if we have any errors. So fly check next error. I think there is no errors in here. So let me do npm run build. So just to make sure that we don't have any errors. I think everything's fine. Okay, so let's do the watch. So now we have more stats. So that's the entirety of the stats. We have this unnecessary stuff. We don't need that stuff anymore, right? We don't need that stuff anymore. Okay, so there's no particular useful information because we didn't start any bots. Oh, right. Average bytes sent per tick. $20 kilobytes, like, bruh. I think we, okay. We're sending too much fucking data. 20 kilobytes. Well, I mean, it's not that much, but I mean, yeah. Batching bot messages seems possible with the current implementation. Yeah, that's why I implemented the way I implemented it. But how will you do that when the messages come from independent clients? Messages come from independent clients. I mean, we're talking about receiving messages. Here we have problem with sending messages. So we send too much data. We don't receive that much data from 20 bots. Right, as you can see, on average per tick, we receive like 350 bytes. This is bytes. But we send out too much information to update all of the bots. It's too much information. We can batch up some of the stuff, but batching up is not going to reduce the amount of bytes we send that much. I think what we'll have to do, we'll have to at some point just switch to binary protocol. All right, so that's pretty cool. Okay, so disconnected now, per tick everything is 0, and that stat stays the same. All right. Okay. That's very useful information. Damn. That gives so many insights. That's very useful. And I hope I didn't make any mistakes while, you know, coding all of that, right? So because that would have been very unfortunate. Why did it still print that 0 at the end? I thought yeah, okay, so that's fine now. All right, so we're done with these things. X, currently players. Well, yeah. Total errors, bogus and bogus messages. What do we do on bogus and bogus messages? I don't really know. Currently players is actually super easy, right? It's available within the players. So I suppose variables are hoisted when used in functions, right? So because it's a scripting language. So what I can do is console log currently players. All right, so it's gonna be that. And is that size? Yeah, it is size. It's kind of bizarre how all of these functions like maps and set, they have size but not length. Right. It almost feels like they were implemented by C++ developers. But anyway, all right, let's try to do that. So currently players should be 0 now. And if I start the bots, run the bots, how many? Yeah, so now currently players 20. So we can clearly see we have 20 players. I can now kill all of them and currently play 0. All right, that's cool. So what's the next stat? Totally players joined, totally players left. Not particularly useful, but it's interesting to know nonetheless. So let me try to do that. So interface stat players joined is going to be a number. Players left also going to be a number. Let's put that stuff in here and initialize that with 0. Emacs, shut the fuck up, Emacs, okay. Console. How did I formula total players joined, stats players joined, and I think players print stats left. Okay, so let me see. When we are handling connections, we're gonna consider that player joined. So stats players joined +1, very easy. And then on close, I'm pretty sure we have close, yes, stats players left +1. So that's very easy. That's probably the easiest stats. We're probably already done with all of the difficult stats. What? Print stats is not. Are you fucking serious? Did I fuck you what? Okay, I put N in there for whatever reason. It's fine. That's totally fine. Everything's fine. Everything. Did I not save? Did it not recompile properly? That's what it feels like. Yeah, it didn't recompile properly. It's fine. It's fine. It happens. Okay, so we're gonna do that. Players joined. Yeah. So totally left, totally joined, and we can now players joined left. So we have all of that statistics in here. Yeah, very useful statistics. Okay, so stats. This one is done. Server uptime. I'm actually not sure if I care about the server uptime. And how do I even compute that? I can keep track of when servers started, right, and then use performance and compute the amount of milliseconds or something like that. Client average latency. To compute the latency, I think we need to do like pings and stuff like that. That's kind of outside of the scope of what I'm doing right now, but we eventually will add that for sure. I'm just adding things that are easy to add. So let me do bogus amogus messages. All right, it's basically the messages that clients sent and that were rejected. So that's basically what they mean, right? So bogus amogus messages, simply bogus amogus. So this one is 0. Total bogus amogus messages. Bogus amogus messages. So how do we do that? Bogus. Yeah, so that's very easy. So like find like these kind of messages and just increment here. Stats bogus amogus messages. Stats bogus amogus +1. And that's it. That's it, I suppose. Right. So first, one of the bogus amogus messages we received is when you send incorrect JSON. If you send incorrect JSON, we first of all will close your connection instantly, right? So, and we're gonna increment bogus amogus messages. So then we expect I'm a moving from you. If you send something that is not I'm a moving but still correct JSON, right, we're still gonna close the connection and increment bogus amogus. Okay, so that's fine. So it's sort of like nice to have, you know, stats. So server uptime. I'm not sure how useful that is, but I mean, we can do that. We can do that. So we can do performance. Well, maybe we can just use like started at, and this is like a number, and started at performance now. Is that a good way to do that? I'm not sure actually. I'm actually not sure. But anyway, so and then if I want to print that stats, so uptime is going to be something like this. So performance now minus stats started at. So probably need to use like a data now. Yeah, probably have to use data now. But I'm kind of lazy to do that. So not data date, And yeah, so I don't know, I need to Google up how to do that, whatever. So this is milliseconds, I'm going to divide it by that, and I'm going to just do that in seconds. So I'm going to do uptime sex, right? So I'm going to indicate that this is sex. All right, so let's see. It's kind of weird, but I mean, it's fine. It's fine for now, right? It could be always improved a little bit later. And honestly, I would like to maybe put it along with the ticks, right? So this ticks by themselves also kind of tell you the uptime of the server, right? They already tell you the uptime of the server. Kind of, sort of, I don't know. All right, that's pretty cool. So I'm gonna just start the bots, and I have some actually useful information about what the fuck is going on. And you know what we need to do, chat. You know what we need to do. So this is bots. This is cool and all, but it would be kind of interesting to collect some stats with the actual people. So maybe the time has come to deploy it to your mom. And your mom is the name of the VPS server where we host things and stuff like that. So yeah, so I already set the limitation to like 69, you know, players, right? So we're not going to have more than 69. It's probably going to be very slow, but so collecting statistics with, you know, with actual people, I think is more useful, because this is sort of like an artificial stuff. So whatever. Okay, so let me do a committee. What I'm going to do. So what I'm going to do, I think I'm not gonna committing bot yet, so you don't use it, right? I'm gonna commit the bot a little bit later. Right. So what I'm gonna do is only commit the stats. Right. Server implement stats. Right. I'm gonna push that. Not into your mom, but origin, right? So into the repo, into the official repo. So there's some, oh, it's basically your mom. All right, so what else did I want to do? I would like to disable some logging as well, right? So because there's a little bit of a problem here, as you can see, right? If I start the server and then I start the bots, so it's going to be bots MJS, the login on the server still logs players connected and stuff like that. Which kind of ruins like the stat view. So I'd like to get rid of that login as well temporarily. So console log, what kind of stuff we have in here? Okay, so so player connected, let's get rid of that. Received bogus amogus message, let's also get rid of that. Let's temporarily get rid of all of the logging. Right, so we don't really care. Right, we don't really care. So server temporarily disable all the logging, right? And I'm gonna push that into the origin. Friend, what you doing? Me DDoSing your mom? Okay. All right, so let's actually push that into your mom. I think your mom is online. Okay, so there's some problems in here. What does she say? Refusing to update checked out branch main by default, updating the current branch not bad. Oh, it's not bad. God damn. So you set deny current branch in configuration to ignore or warn. Yeah, so there's a little bit of a problem with when you do this kind of stuff over SSH if the repo is not bad. Right, so, but I think it's fixable. It should be fixable, right? So let's do SSH your mom. We're into your mom, by the way. We're in your mom. Okay, so let me see. So I'm gonna go into the Git and multiplayer online game. So what's up with that? So somewhere in configs, right? So they say, I suppose it's somewhere in .git, somewhere here. So, and we have config. So you can set receive deny current branch configurable to ignore or warn in the remote repository to allow pushing into the, okay, so let's actually give it a try. I suppose this is what we have to do. And I suppose the receive is a separate like section, right? So receive, deny branch, and I would like to say warn. Is that how we do that? Do we have always push with force? Will force actually force this kind of stuff? I think force will not work here, right? So because what we're doing, we're pushing to non-bear repo over SSH. Oh, by the way, Stefan, you're actually hosting like that, so you probably know about this kind of stuff, but you're probably hosting with bear repos. Right, so you're probably hosting with bear repos, so that should not be a problem. Okay, so I set this config. I only make bear, so yeah, so that's fine, that's fine. So here I just want to have non-bear, and yeah, we'll see. Oh yeah, it worked, look at that. So the reason why they don't allow you to push over SSH to non-bear repos is the following. The reason is it doesn't update it. It doesn't update. So it can take a look at the status. Yeah, right. So you have to like check out like this yourself, right? Maybe you have to reset minus heart. Yeah, and only then it is going to, yeah. So the problem with this kind of stuff is that you have to manually do some additional actions after pushing, but I'm totally fine with that, right? So I'm totally fine with that. Okay, so let me see. I'm going to grab maybe, you know, let me go to maybe SSH. Maybe I'm going to do cut SSH config. Right, so let's take a look at config. So this is what we have in here. And it says 6969. So currently it is not working, but that's fine. That's kind of expected. Right, so in here I'm going to do install. All right, I'm going to do install. Yep. And then I'm going to do run watch. So it is doing things, and I'm gonna just join in here. Doesn't work. Why it doesn't work? Huh, that's bizarre. Refuses connection. Huh. Is that because HTTP? Did I use HTTPS? Maybe I should have used HTTP. Okay, so let's give it a try. Maybe it's because of the port. No, it doesn't work. No, it's not. Definitely not HTTPS. Maybe port is closed or something. I don't freaking know, man. Let me take a look at the watch. And I also don't see anybody connecting either. So we can. Fucking okay. What the fuck did I expect? I mean, sure. So fine, everything's fine. So one of the things we can do here probably just I probably need like a separate like a production run. Right. So too safe. Right, it was too safe. All right, so I'm gonna join. There we go. Seems to be working. Look at that. Everyone go to the left upper corner. Everyone go to the left upper corner. Stream sniping, by the way. Now to the right upper corner. This is so cool. Holy shit, this is working. This is so fucking cool. Okay, so let's take a look at the stats. It's not that much. Average, it's the same amount of bytes per second as well. Right. So, and the amount of players, 45 players. Okay, that's actually currently players. Yeah, 45 players. 46 players, and it's working. Holy shit. Okay, everyone go to the center. Everyone goes to the center. Let's gather in the center. All right, so we are at the center now. Yo, that's so cool. So I added feature that you can actually see yourself, right? So because you now have like a frame. Yep. That's so cool. It's working, right? It's lagging a little bit. But ultimately it kind of works, right? So it kind of works ultimately. All right. So, and most importantly, we collected some statistics, and average bytes sent per tick. Like, oh my god, that's a lot. So we almost actually capped. Okay, we are currently at 69 players. We're currently at 69. We hit 69. We hit 69. Okay, but you can't go more than 69. Okay, I'm actually disconnecting everyone. Everyone is disconnected now. Everyone is disconnected. So yeah, you can close now. It doesn't work, right? So it's just like I should probably implement something that shows you that you got disconnected. Right. So yeah. This game was coded in Germany. Yeah, so the VPS is actually located in Germany. All right, this is a very useful stats, actually, and ironically. I think I'm going to, like, literally grab them, yeah. So we'll see. We'll see how it goes. So, stats. It will be actually better to collect all of them, but I mean, yeah, that's fine. Stats, txt, and I'm going to just put them in here. All right, so yeah, we already streamed for 3 hours, and I think today's stream was actually very much productive, right? So I really enjoyed today's stream. I just remembered I have a non-bear repo set up for deploying my website. It uses a second repo, which is bear, and I just pull from it. You can set origin to be a folder on a disk. Oh, okay, so that's also a reasonable solution. You want a domain? And I actually don't want to set a domain. Like it's much cooler to actually access a server over IP, right? Who do you think we are? We are a community of software developers, of serious software developers. We're not afraid of IPs. We're not some soy dev that see a bare IP and get, oh, what is that? Is that numbers? I don't understand these numbers. What is that? Give me a name. It's just like they're afraid of everything. They're afraid of 4 numbers. They're afraid of bytes. They're afraid of points. They're afraid of everything. We are serious software engineers. We're not afraid of numbers. Anyways, that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Ahu Amista Azozin. I love you. Mwah.